Quantum mechanics is the part of physics that even scientists call weird. That's because it challenges things that we thought were rock solid. For example, the notion of reality. To help explain, I've got a quantum physicist preparing his elevator pitch in what is thankfully a very, very tall building. That tall one. I don't know anything about quantum physics, so you have your work cut out for you.
Awesome.
Are you ready?
Yes, let's go.
Let's go. What is quantum physics?
Well, quantum physics is the description of objects at the very small scale, the scale of atoms, electrons, photons. We want to talk about reality, right?
Okay.
So what is reality?
What we experience?
Yeah, that's about right. So you think the moon is real?
Yes.
Have you been there?
No.
No. So why do you think it's real?
Because it's observable.
Right. I think what you're trying to say is that everybody observes it exactly the same way.
Yes.
Right? And that's what doesn't work with small quantum systems. If you observe a quantum object, you can change it.
It's like how electrons behave differently depending on whether they're observed or not? That
Exactly.
thing? Okay.
So, if I tell you, for example, I have two electrons that want to point in opposite directions, like my fingers, right?
Yeah.
If that's all you know, for example, I hide them behind my back, and I ask you, which way is my left finger pointing?
I need to see one of them to know.
You need to see one of them to know. But the thing is, you can try this experiment many times. You will always find them in opposite direction, no matter how far apart they are.
Down button.
If I had hands that are, a light year long, this would work exactly the same way. But if you look at them from different angles, like from different angles from the lift, from below, from left, from right, you can prove that before you looked at them, my fingers were not pointing anywhere.
Why? What?
My finger was actually not pointing anywhere. It did not have a reality of its own. Yeah, that. And this has been done in actual experiments, been verified. What that means, this is hard to accept, but is that one of the three following things is wrong. One, reality, that things are real, meaning they have a state of their own before they are observed. Two, locality, which means an action here cannot influence something very far away. And three, that we have free choice, like you don't have the choice to which hand you actually look at.
What?
One of those three things cannot be correct, or maybe two of them, or maybe three of them. At least one of them you have to give up to explain and justify the way we observe the behavior of entangled quantum particles.
I have questions.
Good.
And I like having questions.
Good.
Thank you for teaching me about things I need to learn more about.
Fabulous. Thanks for the ride.
So I know I definitely didn't understand everything, but here's what I think I did understand. So we're talking about quantum physics or quantum mechanics, which in this case is the study of very, very small particles and how they behave in relation to each other. So you can have quantum entangled particles which behave in a way relative to each other. So if we observe one, its buddy basically is going to behave in a particular way. And depending on how we observe them, they're going to behave in different ways. But in order for what we are able to observe to be true, one of three things cannot be true, which is either how we view reality, locality, or free will. All three of those things cannot exist whilst what we observe also exists. So it's basically the work of figuring out what we've gotten wrong. And I'm gonna need another really, really big elevator ride to understand all the rest of this. Hey, thanks for watching. Andrea has a bunch of really cool YouTube videos where he explores quantum computing, mechanics, and all the maths behind it. So if you want to see those, click the link in the description. And if you want to see more videos like this, then hit the subscribe button. See ya!